Hi 7th graders, I hope you've been doing well. Today we are going to work on 7.3, which is all about scatter plot. Our learning target is I can display and analyze data using a scatter plot. So let's get started. If we take a look at our vocab word, a scatter plot is a graph with plotted points to show a possible relationship between two data sets. So what it is it's just a graph with a bunch of dots. Okay, so let's go ahead and let's start creating one. So we are going to construct a scatter plot of the number of viewers who watched new seasons of a certain TV show. Alright, so we have all our seasons and the viewers. And then we have our graph, and it's already set up for us, which is super nice. Alright, so our first one, season 1 is 31.7. So that would be somewhere around here. We don't know exactly where it is, but that's a good guess. Okay, season 2 was 26.3. So 26.3 is probably somewhere in the middle there. The next one is 25. 25 is probably a little lower than that. 24.7, so that's even closer to the line. Number 5 is 22.6, so somewhere in there. And number 6 is 22.1. So we just created a scatter plot. Okay, so all it is it's a bunch of dots. We're not connecting them or anything, it's just dots on a graph. Alright, so now we are going to take a look at a word that's called correlation. So what correlation means is if we take a look at this graph right here, all our dots kind of look like they're increasing, right? It kind of looks like they're going in that direction. So what we would call this is a positive correlation. Because as our x value gets bigger, so does our y value. Okay, so when your dots are kind of going up, that is a positive correlation. Now let's move on to the next one. This time our dots are going down. So as our x values get bigger, our y values are going down. Okay, this is called negative correlation. Okay, they're going down. And then the last one we have is when all your dots are kind of scattered. It doesn't look like one is moving up or moving down. So this is called no correlation. When your dots are just all over the place and it doesn't look like there's a trend that's happening. So that is no correlation. Alright, so now we are going to identify the correlation we would expect to see between each pair of data sets. So these can be kind of tricky because you really need to think about how you would make a graph for this data. Okay, so number 1, the number of empty seats in a classroom and the number of students seated in the classroom. So what I like to do is I like to create a little graph over here. Let's say this is the number of empty seats, our x value, and then our y value are the number of students in the class. If we have a ton of empty seats, so if our x value is super high, if there are a ton of empty seats, do we have a lot of students in the classroom? No, right, so our dot would be over here. What about if we have like 0 empty seats? Are we going to have a lot of students in the classroom, or are we going to not have a lot of students in the classroom? Right, if there's no empty seats, we're going to have a ton of students in the classroom. So if we would keep filling up our seats, our data is going to look something like this. So what kind of correlation is that? Is that positive, negative, or no correlation? Right, that's negative correlation. So that means that the more empty seats that we have in the classroom, the less kids are in there. Oops. Not correlation, it's just correlation. Alright, moving on to the second one, the number of pets a person owns and the number of books a person reads last year. So if we think about these two things, the number of pets and the number of books that people read, does that have any correlation? Could we predict, oh, if this person has 5 pets, they're going to read 25 books in a year? No, those two don't really go hand in hand. So this is a no correlation. Totally depends on the person and how much they read and how many pets they have. Awesome, so then our last one is the monthly rainfall and the depth of water in a reservoir. So let's go ahead and create a little graph. The bottom we'll say is the rainfall, or the rain, and then on the y-axis we'll say the water in the reservoir. And a reservoir is kind of like a little lake. Okay, it's like water that's drained from rain. Alright, so let's start with, if we get 0 rain, are we going to have much water in our reservoir? No, we're not, so it would be somewhere down here. What about if we get a ton of rain? Are we going to have a lot of water in our reservoir? Yeah, it's going to be pretty full. So our data is going to look something like this. Is this positive, negative, or no correlation? Right, this is positive correlation, so that is your answer. Oh, sorry, that was kind of sloppy. Alright, so now we are going to move on to line of best fit. Line of best fit is a line that shows the correlation between two sets of data. So I kind of drew a line of a line of best fit in these two graphs when we talked about positive and negative. So that's all we're going to be doing in this one. So if we take a look at the MP3 players graph, are those numbers getting bigger or are they getting smaller? Right, they're getting bigger. So we know that this is going to be a positive correlation. Okay, and then taking a look, we need to draw a line of best fit. Now we're all going to draw lines a little bit different. No one is going to make our lines exactly the same. So what you're going to do is you're just going to do your best at making your line kind of be in the middle of all of your data. So that's how mine is going to look today. Okay, there's some data on top of the line, there's some data on the bottom, and it's kind of in the middle. Okay, so now taking a look at number 2. This time, is it positive, negative, or no correlation? I agree, this is not no correlation. This is negative correlation because our numbers are getting smaller. Okay, so now we need to draw in our line of best fit. So to do that, do your very best at making your line somewhere in the middle of all of your data, and then draw your arrow on the end. So that is a line of best fit. Alright, and we have one more. We are going to create a scatter plot for the largest vertical drops of 9 roller coasters in the US and the number of years after 1988 that they were opened. So we have a whole bunch of data. Our first step is to first create the scatter plot. So 1 is 151, so we're going to go over 1, which is somewhere in here, and it's 151, so that's super close to the line. And then 3 was 155, so 3 is right in here. 155 is just a little bit higher. 5 is 225, so 225 is going to be like right in the middle. 8 is 230. So that's going to be a little bit higher. 12 is 306. Another 12 is 255. A 13 is 255. And a 15, which is right here, is 400. Alright, so taking a look at that data, we need to draw a line of best fit. So do your best at drawing in that line. It's not going to be perfect, we know that. And then we need to identify the type of correlation. Is this positive, negative, or no correlation? Yeah, our numbers are getting bigger. This is positive correlation. Alright, so then number 3, predict the vertical drop of a roller coaster built 30 years after 1988. Alright, so right now this only goes to 15 years after. So we need to think, like envision a whole nother graph here. Okay, if this is our graph, here's what it looks like right now. In 30 years, how high is it going to be? How high of a drop do we think it's going to be? I'm going to take an estimate. We don't know exactly what it is, but if in 15 years it's almost to 400, our line of best fit is almost to 400, I'm going to add about 200 to that. So I'm going to say that it is going to be about 600 feet. And that is our answer. We're all going to get different things for number 3, and that's totally fine. You just need to make an educated guess. Now here's where I would mark it wrong. If you said that in 30 years after 1988, our height is going to be 50 feet, would that make any sense? No, it wouldn't. So it needs to be somewhere in the range of making sense. Okay? If you have questions about that, please let me know. Otherwise, I hope you have a fabulous day.